Good evening and welcome everyone. This is Manish Nath from Hex-Star Universe and I'm going to be your host for today's session. First of all, we want to thank everyone for taking their time to join us today. Now, before moving forward with our webinar, let me give you a brief introduction about what is Hex-Star Universe. So, Hex-Star Universe is basically a space education and research-based platform which helps students to pursue their careers in the field of space science and technology. We
Good
are on the
evening and
mission of
welcome
building the
everyone. This
biggest
is Manish
community of
Nath
space
from
science
Hex-Star
and
Universe
technology.
and I'm
We
going to
give
be your host
opportunity
for
to the
today's
students
session.
to work on projects
First of all, we
related to
want to
space
thank
science.
everyone for taking their
Now,
time to
coming
join us
back to our
today.
main event, our
Now,
topic
before
for
moving
today
forward
is
with our
Life
webinar,
Beyond
let
Earth.
me give you a brief
This
introduction
evening, we
about
have
what is
Mr.
Hex-Star
Anuj Soni with
Universe.
us as our speaker. So,
He
Hex-Star
is a
Universe is
geologist.
basically a
He is
space
also the head
education
of
and
the Department
research-based
of
platform which
Astrobiology
helps
at
students to pursue
Supernova
their
at
careers in the
Spaceonova,
field of space science
one
and
of the leading
technology.
space education
We
and
are
a
on the
research
mission of
based
building the
platform in
biggest
India
community of
and
space
also
science
a member
technology,
of
and we
Q1,
give
one of
opportunity
Earth's
to the
first
students to
exploration
work on
program in
projects
India.
First of all, we want to thank
We are
everyone
really
for
thankful
taking
to
the
him for joining us today. So without any further ado, I would like to request Anuj sir to proceed with today's topic. Thank you everyone, and this is all from my side.
First of all, thank you so much, Manish, for the very nice and a very warm welcome. So, I just want to know a very first thing. Are you guys excited for the today's session? Because this is the something, the topic is something that you can understand, you can talk about. Like you can think at once, like, does really life exist beyond Earth? This is the very first question that comes in your mind. So with this, I actually want to share one link with you. Is this is basically I made a post, LinkedIn post, few days back. So that was just for you guys to just go there and comment there if you are excited for this session, and just let me know that yes, you are extremely excited for the session and what you want to know about it, right, for this topic. So I'm just clicking here and the link is in the chat section. Just go there and comment back and just let me know that yes, you are excited for the session, and then we will begin, right? Just go and comment there and we'll begin within 2 minutes. And meanwhile, I am sharing my screen. Okay, just let me know if it is visible or not, right? I guess it is visible. Manish, can you confirm me? Is it visible?
Uh, yes, it is visible.
Okay, cool. And just let me know, then we'll begin, right? So, okay, so let's just begin with the session. So, hello guys, I'm Anuj Soni. I'm the head at Department of Astrobiology at Spaceonova. So, we also share the same vision and the same theme as the Hex-Star universe does. So, as I already told you about the life beyond Earth, this is one of the most fascinating topic that you ever heard of, right? Because this is something that intriguing us. Like, does really life exist beyond Earth? And what could it be? Like, how does it look like? And what sort of changes they had occurred than others? Because what we know till now, we have shared some privilege. Earth has some privilege like we have on, right? So to to myth bust all these things, we have a today's session that is life beyond Earth, right? Now let's just move with the session. Now the very first thing we have to understand, what are exoplanets? Because we know there are some other planets that actually lies beyond Earth. right? If you can understand, if you can feel this, give me just 1 second, okay? Give me just 1 second. I'm just sharing once again. Right. Okay. Is it visible? Manish, can you please confirm me? Is it visible, right?
Yes, sir, it is visible.
Okay. Okay. Now, okay. So as I was talking about that, what is exoplanets, right? Because this is something we need to understand. So to be honest, nothing, whatever planet you have found beyond our solar system is called as exoplanets, right? Or even you can call it as a moon. Now, you have find something which looks like a planet and but it is belongs to, far away from our solar system, that this particular planet called as an exoplanet, right? So far we have discovered around 4,000 confirmed exoplanets. Yeah, this is the basic number of exoplanets that we have detected so far with the help of a space-based telescope, with the help of land space telescopes. So yes, but the question is, out of these 4,000 plus exoplanets, how many planets have life? This is the question. And what type of life could be? Is it microbial or more complex life, or maybe an advanced life like an alien? Right? So these are few questions that we have to identify, and first we have to look for the planets, that planets which is in its habitable zone and which harbor life. But before that, before that, we first have to look for life on Earth, like how life formed on Earth itself, how life originated on Earth. This is the very first question. Then once we understand, okay, this was the process, these are the things that are needed to form a life, then we'll jump on to the exoplanets. So for this, what we have to do is, let's look into it, how life form. So what needs to form a life? The very first thing is the energy. So if you have the energy, like living organisms are created by chemistry and we are a huge packages of chemical elements. And what are the optimal conditions for this chemistry? We need sunlight, we need geothermal energy to form life, and this is the very first ingredient that you need to form a life. Well, as you already need, as you already understand, okay, energy is something that you need, but not too much, because it just need a right amount of energy, and then planet turns out to be located at just close to the star, but not too close, so that the whatever the water you have in your planet, that is burned out as a gas, and not too far, because by that whatever the liquid water you have, that will freeze out. So the optimal place is required, that we call it as the habitable zone, and here is only our earth is there, right? So after that you need a chemical elements, then you all need a range of chemical elements. On these chemical elements, maybe a carbon, nitrogen, oxygen, sulfur, because we know these are some basic elements that form life, that form organic compound, right? And after that, what you all need? You need water, a liquid water. So what about gas and what about solids? Well, in gas, atoms move past each other so fast that they can't stick together. And in solid, atoms are stuck together. They can't even move. However, in liquid, atoms are cruise and curdle and link up together to form a molecule. That's why liquid water is the prominent thing that you can look for life. Now, what if you got each and everything at a place? Energy, chemical element, liquid water, then what happened? Something happened like happened on Earth a way back. Around 4 billion years ago, this was our Earth having a liquid oceans and some sort of, you know, internal heat. That internal heat ultimately leads to form a hydrothermal vent, because now we understand life was begun somewhere in the hydrothermal vents beneath the ocean, under the water. So yes, life was began somewhere around 4 to 3.8 billion years ago near hydrothermal vents. Now we understand this is how life formed, and what ultimately it takes. It takes the evolution, that far evolution that leads us to we as humans, the advanced civilization for our own Earth. I'm saying for our own Earth, not for the galaxy and not for the universe, right? Because whatever the life we have known so far is us. This is the thing. Now, if life is possible on Earth, then what about these planets? These are all nothing but exoplanets. So this, it gives us a hope. Since life is possible on Earth, then there are billions of planets that are, and even some of them have a liquid water. So let's find the possibilities of life within our solar system, because we can't directly jump onto the exoplanets. So we have to look for sign for life in other planets, but within our solar system, right? So at first we have Mars. Now the question is there life on Mars? Because currently the scenario is something like we all talking about, we all talking about Mars, that we have to go to Mars, we have to live there. Is there water? Is there running water? Is there a river? Is there a lake? And all these sort of things. Because it is the very nearest planet to us. And also, it is also sharing some geological similarities between Earth and Mars. That's why we are Mars. But the thing is, we can't find what liquid water is there, right? Now, so have we detected life there? This is the question. So to answer this, first we have sent Viking 2 mission. This mission was from a NASA, that is Viking Lander 1 and 2, and both they have some kind of instrument that actually detects the traces of life. But this whole mission goes failure. But I can say a partially failure, because these both landers haven't or neither found any traces of life, but they find all the essential elements that can be form a life on Earth, such as carbon, nitrogen, hydrogen, oxygen, phosphorus, and maybe sulfur. The same ingredient, the same element that we earlier discussed for the chemical element that is essential for life. So yes, this gives us a hope that yes, there can be something to form a life. What just need? We need an energy that is sun is continuously giving it. That is in planet's internal energy. That is our geohydrothermal energy. Now what we need? We need liquid water. So have we detected any traces of life there? So to answer this question, We recently sent a Perseverance rover there in the Jezero crater. Now, why Jezero crater? Because Jezero crater is showing actual the candidaticity for the life, right? Now, why exactly so? Because Jezero crater, because Jezero crater have a river delta, and that river delta itself saying that yes, there was a liquid water and actually a stream water that is flowing and covering the whole crater into a lake. So in that lake, if we find a stromatolites, these structures basically are stromatolites, right? Now the question is, what are stromatolites? These are actually formed by the organism called as blue-green algae. If blue-green algae was there and they ultimately consolidated and to form a solid structure that we called it as a stromatolites. If we can detect them, we can actually conclude this, okay, there was a time when life was there. Although that was a microbial life, but life was there. So Perseverance is ultimately finding these structures near the Jezero crater, and if it is able to find these structures, then we can conclude that yes, at some ancient past there was a life on Martian surface. So let's understand what exactly stromatolites are. So basically, stromatolites are considered to be the very first evidence of life on Earth, because after the finding of stromatolites, we can say that okay, around 3.8 billion years ago, life was formed on Earth. That is a blue-green algae, cyanobacteria, right? So whether they are even on exist on Mars, that remains to be seen. We have to see for that. We have to look for these signs, right? And generally, as I already told you, that it is a layered rock. When a microbes, consolidated, they ultimately forms a rock. So this is what a piece of rock looks like, right? So ultimately, so stromatolites deposits forms by the sedimentation and trappings and bindings, right? And by the precipitation and the activities of microbial communities, right? So this is what we can find. And as you can understand what is the work of cyanobacteria, what is the work of blue-green algae, they takes the energy from the sun and they photosynthesize and release the oxygen as a byproduct. That oxygen will helps us to understand that yes, there was a oxygen, there was a plantation, and there was a life on early Mars, right? So this is just one of our closest planet that we are thinking about at some some far future that we can colonize there. Now after that, it's time to move beyond Mars. Somewhere in the gravitational influence of Jupiter, where one moon is showing a sort of potentiality of life. What is that? That is Europa. And what it caps beneath its icy shelf. Why we are so much fascinated about this particular moon, this Jupiter's moon. And wait, what about Enceladus? Enceladus is also sharing the similar kind of geology, and you can say the characteristics that are similar to Europa. And Enceladus is the moon of Saturn. Now, let's compare the internal structure of Europa and Enceladus. So yeah, this is somewhat Europa looks like from the inside out, and this is the same Enceladus that looks inside out. Now, if you remember, if you remember, on Earth, life was found somewhere like similar to this scenario and the same conditions. As you can see, the energy, the geothermal energy that is continuously providing and providing through these hydrothermal vents, and plus a liquid water, energy is there, chemical elements is there, and water is there. What could be? There could be a life, but just the need is we have to go there, we have to study it, we have to analyze it. So Europa shares a thick surface of icy crust, and beneath there is a liquid subsurface ocean. And this ocean's amount is that much huge that even our oceans have the equal amount of liquid water in just beneath this icy shell. Now, similarly, Enceladus also resembles with the same. It also have some geothermal vents, geothermal hydrothermal vents, which ultimately leads to, gives out some geyser like structures, these surface geysers. And these are all happen due to the pressure generated due to the heat, due to its internal heat of moon, internal heat of Enceladus. Now, when the Cassini rover, when the Cassini spacecraft was flying by through this moon, it actually captured some sort of chemical elements, and that chemical element, that chemical compound, was nothing but an organic compound, which leads us to say that okay, there was something was going on beneath the icy cell. There was something happening beneath here that ultimately leads to form a life, and it has a prominent ingredient there and prominent things, right? So this is the whole story of Enceladus and Europa. Now, what about Titan? A Titan, a world of liquid organic compound. Well, the organic compounds are nothing but hydrocarbons, methane, ethane. And it has been suggested that yes, this Titan world have oceans of methane and ethane. There is a huge amount of methane gas that is nothing but you can say it is a greenhouse gas, but also it is providing some heat to the planet, this moon. And the liquidity of that ethane and methane provides a very significant sign for life. That's why NASA is planning to send a dragonfly. Dragonfly is a drone type structure actually that can actually fly at the atmosphere, the thick atmosphere of Titan, to sign for life. This is what it is happening now. Okay, so these are few moons and planets that now we know, and that there are some other planets and moons in our solar system which are potential for life. Now, okay, if not complex, but at least microbial life could be formed possible there, right? If not complex, at least microbial life could be possible in these planets and these moons. Now now think about the possibilities of life beyond solar system. There are multiple sun-like stars out there, and some of them even have planets. So the question is, have we found any? Have we found any planets that suits and that comes under the same category of life? So the answer is yes, we do have detected. Now, the planet is Kepler 62f, a super Earth-sized planet and about 1200 light years away from us. So yes, Kepler Kepler 62f, a super Earth planet, is a habitable in its revolving around in its habitable zone around a star, and a star is pretty much smaller and cooler in temperature than our sun, as we can understand that it is a red dwarf star, right, and which is located around 1200 light years away from Earth in the constellation of Lyra. Yes, this is important, in the constellation of Lyra. Now, this particular planet that Kepler 62f is orbit its host star every 267 days, as we are revolving around sun in 365 days. So this particular planet is revolving around 267, you know, star days, you can say. Now, it is roughly around 40% larger than the size of our own Earth, right? And this size of Kepler 62f F, and we actually needs to know about its mass and its composition, because this is they are not confirmed, but yes, we can see and we can understand with the mass spectroscopy method that this planet have a potentiality of liquid water because it's in its habitable zone, right? So these are some things that we have to understand. Now we have the TRAPPIST 1D. It is a Earth-sized planet, and it is quite near to us. That is 40 light years away only from Earth. Now the thing is, this is one planet out of these 7 planets of TRAPPIST-1 system, and this actually showing the possibility of liquid water or ice on its surface. It is actually revolving around around a red dwarf star. TRAPPIST-1 system is a star which is a red dwarf. That's why the habitable zone is it's quite very near to it, not too far as compared to our own habitable zone, right? So these are the things. So that's why it is the prominent place to find liquid water on its surface, right? Then we have Kepler 186f. So this particular planet is itself equal size of Earth, but it is around 500 light years away from us. Now, NASA Kepler's telescope have discovered the first Earth-sized planet orbiting the star in its habitable zone. So the range of distance from a star where the liquid water might pool, right? As you can understand, because the habitable zone is somewhere a liquid water can sustain. So the discovery of this Kepler 186f confirmed that the planet, the size of Earth exists in the habitable zone of a star. It's more like revolving around a G-type star that is nothing but our own sun is. So this gives us a hope. The same kind of size we have resembling it, the same kind of sun we are sharing, right? So this actually gives us a very strong hope to find life there. The reason why I'm saying this, because this particular planet, that Kepler 186f, is have the axial tilt of rotation. Now, what is the axial tilt of rotation? This is the some rotation that same we share in our own Earth, that we have a 20-degree tilt, axial tilt. That's why our Earth is revolving something like this, right? And due to that tilt, it has some seasons. So this planet also have seasons due to its tilt. Now you can understand the clear and the very, the thing that is very clear, that yes, if we can look into it, if we can find something on it, this might be possible to find life on its surface, right? Then we have Kepler-22b, a super Earth size but located around 600 light years away from us, and we also called it as a Earth 2.0. Now the question is why we are calling Kepler-22b is a Earth 2.0. The reason is because this planet have the sufficient amount of liquid water as well as the potentiality of a surface, a terrestrial surface. Now what you need? You need you need a sort of energy that is its internal geothermal energy is itself providing it, right? And the solar energy that it is gathering from its host star. What ultimately leads? It leads to form a life. So anyways, so in 2011, this Kepler mission had confirmed the very first planet in its habitable zone, that is a Kepler-22b, and it is about 6.3 Earth masses, right? And its surface temperature is, the average surface temperature is 22 degrees Celsius. That's why we call it as the Kepler 22b. 22, it's actually dedicating to its the temperature of its this planet, the temperature of this planet, right? Now we have now we have the probability to find land and water at the same place. This is something that we have to look for, right? Now the another third interesting thing is, although this planet is tidally locked, yes, this planet is tidally locked to its host star. That means it is continuously facing one side to the star and the another side is continuously facing a dark day, the dark night all over the year. So yes, so as you can understand by this, that this particular phase of planet is always showing the light and this particular phase is always showing a darkness like our moon. After that, we have Earth, our own home that we know so far that life is something here. We can find life here. We can see the variety of life here. We can see the variety of creatures here. A lot of species is there. Even some of the species that even we don't have identified due to the remote, uh, due to its remote regions, because we can't even reach the deepest portion of our own earth beneath the ocean. Because of its high pressure we can't reach there, and because of some islands that are actually, you know, located at somewhere that we can't reach there, there might be a diversity of life. But the thing is, first we have to explore our own earth, and the ultimate thing is, you know, our earth itself showing the possibilities of life beyond earth. The reason why I'm saying this is you can't reach these exoplanets directly, right? You can't reach to other moons in our solar system itself. You can't reach to into the Mars in the very near future. Like you want to go to Mars in like within 1 year? No, it's not possible. You can't reach there. So we have to look for certain places in our own earth that actually resembles with the same kind of environment and same kind of geological places to these planets, such as we have to find some analog sites for Mars, we have to identify the analog sites for Europa, we have to identify the analog sites for Enceladus. So before going into that, we have to understand our Milky Way alone have around 50 billion worlds, Earth-like worlds. So in the entire universe, the possible number of habitable planets is staggeringly high. There are 2 billion galaxies in our observable universe, and they are too far away from us to study a practical knowledge about these planets and to study practical, to practical study for these planets. So we have to seek for analog sites to enhance our practical knowledge about these planets and about these conditions. Why we have analog sites on Earth. Now the question is, what is analog site? So these are the places that actually resembles with the same type of planets and moons. This is basically to understand life in these planets and moon, right? And these planets called as analog sites on Earth. Now, what are they and where are they? Right? So, as you can see, Concordia Research Station that is actually located in the Antarctica, and this actually resembles the similar kind of the analogy that shares with Europa and Enceladus. So we have the analog site, and as you can see, these boxes are nothing but a place where the researchers are actually doing their research work and to understand the possibilities of life in these harsh conditions and these remote conditions. Then we have Mars Desert Research Station, that is MDRS at Utah, USA. So as you can see at the background, the similar analogy, similar kind of analogy that resembles with Mars. And these are some, places where the scientists actually live for a long duration, such as their like 6 month and for a year project. They have to collect the samples and to understand life and the possibility of life, like how life originated and these harsh conditions that are actually resemblance, showing the resemblance with some distant planet, for example Mars itself. So yeah, we have these kind of places where actually astrobiologists are doing their research, right? Then we have a Yellowstone hot spring. Now why we are calling it as analog site? The reason is life was originated somewhere in the hydrothermal vents and somewhere in you can the hot springs, you can say the hot spring, where the hot soup is generated due to some organic compound and the liquid water and the high temperature. That's why we have, that's why we consider Yellowstone hot spring as a sign for life for a microbiologist, right? Then we have a flashline Martian Arctic region and a research station at Canada. This is also a similar kind, shares a similar kind of analogy to Mars. And this is the research station there we usually do our researches there. And then we have Mars Amity Research Station, that is Mars at Ladakh in India. So yeah, even India is also showing the similar kind of analogy to Mars. That's why we have analog sites on our India as well. Then we have the Lunar crater. Now, why we are calling the Lunar crater as the analog site? Because these lunar crater is actually made of due to the impact, due to the impact of meteorite, and that meteoroids is the same kind of meteorite that actually created a Jezero crater on Mars and have the same liquid water. And then we are actually supposing that there was a liquid water on Jezero crater. So this actually helps us to study the analogy of that crater, right? So, and there are various another other places on Earth itself that actually showing the resemblance to these planets and to study life there. And that's what astrobiologists do, these research work. At last, like as I was the crew member of ESEP program, so I visited the Ladakh analog site, and what we do there and why we went there, because it actually showing the same kind of environment there. As you can see, the whole background that you can see, it's something looks like we are on the Martian surface and doing our research. Yes, this is something that we were looking for. So in near the hot spring, we found even something related that is nothing but a cyanobacteria and some other bacterias that was flourishing there in their hot spring at that much altitude. So this brings us to help to study a life there, like how life evolved there. If we can understand that, we can actually consider the same kind of thing on other planets such as Mars. Then we have even found a Puga hot spring at Ladakh. As you can see, this is the hot spring, and the hot water is coming out of the ground in the form of groundwater. So we have detected some kind of life there that was flourishing there in a saline condition. So they were basically a halosaline organisms. So yes, this leads us to study for, what I can say. This actually leads us to study for the extremophiles. These extremophiles is actually helps us to study life beyond solar system and to identify why the life is possible out there or not, and what kind of harsh condition that life can be formed, right? So before finding life on exoplanets or any other planets, first we have to look for the similar kind of places that are present on Earth itself for now, to study life better and to think about the possibility of life beyond Earth, like for example on Mars, right? So yeah, this is all about the today's session, and yes, now you can ask any questions. I'm feel free to answer the things. Yes.
Well, thank you, Anuj sir, for your wonderful presentation on this really interesting topic. I think all the participants are really helped. And now we can proceed towards our Q&A session. So participants, those who have questions related to this topic are requested to raise their hands, and we will allow unmute their mic and you can ask questions to sir. And mic will be allowed one at a time and we will call out their name. Okay. Okay, first Aradhya Mittal. Aradhya, you can ask question to sir if you have any.
Okay, like she's saying she's unable to unmute. I guess she was talking about she is not able to. Yeah.
Aradhya, you can try once more because we have unmuted your mic now.
Okay, so she is not able to do so. Yeah.
Okay, so Aradhya, I don't know why this is happening, but you can, if you can ask your question in the chat.
Okay, so I see Vijay. Okay, thank you so much, Vijay, that you liked the session. Okay, Aradhya was asking about to explain the analog sites. Okay, so basically, like you want to do research on Mars or a Martian surface, but the thing is you are not able to reach there, right? So what you can do is you can find some places on Earth itself which is actually resembling to these places, right? For example, we have Ladakh itself in our India. So what we can do there is we can find a certain places, like for example, I already told you about the hot spring that we have found on Ladakh. That is, Ladakh is actually situated in a very high altitude, right? So as you can understand, even the possibilities of life that we have looking for on Mars, it's somewhere in the high altitude itself. So the thing is, as we find uh, you know the what I can say, the hot spring, and that hot spring have the liquid water and having the geothermal energy. What you need a chemical compounds, you need the chemical elements. Now when you provided with the certain amount of certain kind of elements that are actually lead us to form a life, so this is ultimate the goal of your study. And what we found there, we actually found life there in the hollow saline, the highly saline condition, because the water that was coming out of from the spring, we we actually detected the salinity of that water, so that was highly saline, and even the temperature of that water was around more than 50 degrees Celsius. So that is the water which is in the state of boiling, right? Like if you put your finger might burn. Even at that condition, life was flourishing. So this is what astrobiologists do to understand life in these harsh conditions and to relate the same thing with with the cosmic perspective, that if life could possible here in these conditions, what could be the possibility to form life on other worlds with the same condition or with the other conditions, right? So this is why we choose analog sites. Like for example, we have the analogy site for Europa and Enceladus in Antarctica. So as you can understand, you are actually living on the icy shell, and beneath that icy shell there is a liquid ocean, right? The Arctic Ocean beneath your icy shell. Now this actually helps you to study the similar kind of thing that you can find on Europa and Enceladus. And even we do have some sort of, geothermal activities there. So based on these geothermal activities, we can actually understand, like beneath the ocean, we can even found some sort of traces of life. If we can find the traces of life there, then we can actually estimate that, and we can actually analyze the same kind of thing. Okay, we can find the same thing on Europa and Mars as well, because in the slides you have observed that there was a geothermal vent right beneath the ocean, right? So this is something brings us to study and to broad our spectrum to think about life. So yes, that's why we have analog sites. This is nothing but a place that actually resembles to other planets or other moons on Earth. Yeah, this is the whole brief about the analog sites. Yes, and yeah, Manish, any other questions do they have?
Yes, just a second. Okay, Nitesh, you can ask your question now.
Am I audible?
Yes, you're audible.
My question is that if aliens exist, would you expect them to be intelligent creators or simple microbes?
Okay, okay. Well, thank you for the question, Nitish. This is some of the exciting questions that I have encountered, and many of times, like people ask me about the same thing. So yes, now the possibilities of life on other worlds, whether they are advanced in the form of aliens or other or either they are a microbial. Now, this is the thing of perspective because the life evolved on earth that so much early, like earth was formed around 4.5 billion years ago and the life was formed around 4 billion years ago, right? In a very short span of time, life was evolved on earth, and from that period of time to now we evolved. Now, think of the possibilities of life, of planets. I'm not saying life, I'm talking about right now planets. Think about the possibilities of planets that are similar to Earth, because there are billions of stars out there within our galaxy. And there are billions of planets that are actually revolving around these suns and these stars. Right now, there is one equation called as the drag equation. It is actually given by Fred Drank, and he was astrophysicist and astronomer. So he actually created a one formula called as drag equation, and it is nothing but helps us to find the possibilities of the advanced life within our galaxy. Within our galaxy, I'm saying within our galaxy, right? So he created a one formula, and that formula is something around something like this, like what is the number of star that formed within our galaxy? What is that number of star that born every year in our galaxy? Then out of that stars, how many stars have planets that is actually revolving on its habitable zone, times how many planets have showing the the candidity of to form a life. I'm saying the candidity, not exactly to find life, but the candidates for life, right? Times how many planets, and out of these planets have potential to found a life in the microbial form, times what is the percentage, or you can say the fraction, that that particular planet to evolve from microbial to a intelligent life, times that planet is capable of to build some transmission, what you can say, the transmit communication instruments for, or you can say the use of techno signatures. To find the techno signatures, they might be able to send some messages with the help of radio wave signals, times ultimate thing is how long they are detectable in the universe, the time length of that civilization. And to be honest, the amount of or the length of time that any advanced civilization shares around 20 to 50 thousands only. Yeah, 20 to 50,000 is the length of year that advanced civilization can survive for that planet only, right? So this is the thing. So out once you calculate and put the all values into it, then you find there are 10 civilizations within our galaxy that are advanced like us, or maybe more than us. So like we are finding sign for life as a biosignature, to find a advanced life we have to look for techno signatures. Once we are able to find technosignatures, we can say that yes, this might be alien life, but advanced more than us, because they they can harness the power of our own planet, like their own planet. They can harness the whole energy of out of it. So these are some criteria that we have to understand to compare and talk about the life that is more advanced than us. So yeah, I think drag equation is something that actually defines the both kind of thing, that is microbial to advanced life. That yes, this is the all about your question. And if you have any questions, yeah, yes, you can ask as well. Yeah, any other questions?
Thank you, sir, first of all, your answer.
Yeah.
And I have another question. Do any exoplanets have rings?
Rings, yeah, there are many planets that have rings, right? It's not our Saturn only. There are multiple planets, and even like when I was studying one of the article that I found, there are around in that particular paper only, right? In that particular article only, there are like 5 to 7 planets out there that having rings that we have detected so far, right? That means there are lot of planets that have rings, but the thing is we have to look for them, right? Yeah. Now, and maybe in future you find some of the planet that have rings and even have life too. This is just sort of thing, because our universe is so vast. We have, if you are looking at one place or a one direction, you are actually neglecting 250 sorry, 359 degree. You are actually left in that part, because you are focusing on just 1 degree. So this is how our universe is vast, right?
Okay, next, Abhishek Sharbukan, you can ask your question.
Hello, Anuj sir.
Hello,
Thanks for
Abhishek.
the session. You were talking about Lunar Lake, that lunar crater,
Mm-hmm.
and we know that I have attended your previous session, and you talked about the deltas that are present
Yeah,
in
yeah.
lake. So, are you aware of any future research that is, or any program like you talk about Ladakh? Is there any program or something? Are
Yeah,
you aware
it's
of anything
yeah. So
around
I
the place?
yeah, I want to talk about that only, right? Even Spaceonova is coming with some of the expedition programs very soon, right? So right now we have like officially collaborated with Shulani University, right? And we are actually planning to, conduct one expedition program in our own India to find some analog sites. So we are even planning for lunar lake as well, to find or to study some kind of extreme, you can say the extreme life, because that particular lake have the high salinity, as we already know. So if life is possible, and life is clearly possible there, because there was a lot of plantation that we can see, that means they have somehow adapted themselves, right, to flourishing there. So that's why we are actually planning to conduct some of the expeditions from our side as well, to understand astrobiology way more clearly and way more properly. And out of that, we are ultimate goal is to write our research papers and research articles that ultimately we are going to publish in some of the international conferences such as AppGradCon and ISC. And along with that, we are even planning to prepare few of the research papers that we can publish on some of the astrobiology journals. So yes, this is what our ultimate goal is. Yeah.
Okay, next, Palash Karthik, you can ask your question.
Send it on the chat.
Yeah, okay, Palash. Okay, I got your question. Like there are multiple sections in your one question itself. So the very first question, like how we, name these planets and galaxies. So yes, there are some rules. Like when I was talking about, that Kepler 22b, Kepler 186f, and Kepler this and Kepler that. So we actually name them according to the telescopes. Like we have a telescope that is Kepler Space Telescope. So whatever the findings that that particular telescope found, we name that particular planet based on the telescope that have found. Now we right now we have a test which is in its active state and actually detecting some of the planets out there. And right now we just launched our jam web space, right, web space telescope. So what he does, he will all like that particular telescope is also detecting some of the planets in pretty much more detailed way. Like, so there is a certain rule and there is certain you can understand the way of giving a name that was already there. And based on this, whatever like whichever the instrument have detected, we can name it according to its catalog, right? So yeah, these are the some things that's how we give the name. And then you asked, can we have some universal set of rule dimension? Actually, you as if we find intellect life and then we would uh, universe is so vast, right? Like as I already told you, you have and we can't actually think that we are the only one and we are the rulers and we have to give names, right? But what we can do, whatever the thing that we are creating and whatever that created thing that is telescope is actually finding, based on that only we can name it. Because like suppose you want to create a one universal rule, right? We have only 25 letters, alphabet letters, right? But we have a large amount of numbers. Like suppose if I'm talking about there are billions planet out there in our universe, then how will you call it? Suppose you reached at the certain amount of uh, a value that is this much billion. Now, how will you pronounce it and how will you say it, right? So that's why what we are doing, whatever the instrument that we have created, we actually allow them to write in that way only, right? According to the telescope and according to the instruments and according to the scientists that have created, right? So this is the whole thing. Then this is how we created our rules and this is how we created even our catalog for naming the stars. So yeah.
Thank you, sir.
Okay, next, Vodela Sai Avinav, you can ask your question.
Hi, sir. This is Saadne. My question
Hello.
is, how far from the Earth can humans travel?
Can you please come again?
How far from the Earth can humans travel?
Manish, if you can please let me know, like I'm not clearly, you are not clearly audible to me. Or even if you can
Yes.
write it on a chat. Yeah, yeah, yeah,
Yeah,
Manish, please.
his voice is not clear, so please, you can, if you can write in the chat. Yeah. And others, please don't write your
Am I
question in
audible?
the chat. Yeah, you are audible. Yeah.
How far from the Earth can humans travel?
Okay, okay, got it. Like how from the Earth humans can travel. So we have created a one spacecraft that actually, leave our own what you can say the solar system boundary. That is nothing but a Voyager 1. Like, but that was a spacecraft, right? And it has some sort of message attached to it. We have the golden plate that is attached on that particular spacecraft that is actually carrying our voice, our greetings to whatever the civilization, like maybe in future, whatever the civilization that received that spacecraft and taken out these record golden record and starts to play and to listen our voice, our greetings from earth. This is the thing that we have sent it till now. Now the question is how far we can go. It actually depends on time. It actually depends how much advanced we are in that with the technologies, right? Like if you are able to create that technology that can actually reduce our time to reach somewhere in a very short span of time, that means you can actually travel a lot, you can cover a lot distance from whatever the previous spacecrafts and rockets that we have created. Now the thing is, usually people talk about the Starship and all these sort of web drive. This field actually needs to be more productive, and this field actually needs to be you can say more have a more intellectual people to actually think about it, to create some sort of some sort of technologies that can actually have the applications of it. So we have to find that also, right? Because violating a space laws and the physical laws, like this is something that we can't do because science never lies, right? We all know science never lies. So the ultimate thing is we have to adapt ourselves in such a way to develop such kind of technologies that is that can actually travel more than the speed of light itself if you want to reach there. But ultimately the thing is it is not possible to travel more than that speed of light. In something itself we are violating the laws of physics. Now if you want to travel 40 light years away from here, there is one particular planet that you want to reach there that is habitable, that has liquid water, that have land surface, that have the perfect amount of light radiation and getting some sort of energies from the solar its star. Now the thing is if you are creating something which is equal to the speed of light, it will take a 40 years to reach there. Now once you visited there, now you want to colonize that particular planet, right? So again you want to bring some peoples from earth itself, right? So again it will takes a 40 more years. So ultimately the distance is the problem. But if we have like one sort of idea of creating like, have you ever heard of that breakthrough project, breakthrough listen project? If not, you are not aware of, we are actually using the technology of that sailing. We are actually using the laser beam, like highly intense laser beam that will actually gives you around 20% of speed of light, right? Like suppose if you are you want to travel a 4 light years distance, the distance is 4 light years away, right? So that will take, yes, exactly, the pure Priyanshu is saying the solar cell, exact the same concept that I'm talking about. That 4 light years distance is itself taking around 24 years to travel that time only. So we are actually developing and we are actually thinking about these kind of stuffs, but we can't say how much, what is the distance that we can cover. We can cover a lot of distance, but it takes a lot more time to develop that technology, right? So yeah, this is the thing.
Okay, next, Arnav Bidari, you can ask your question.
Uh, am I audible?
Yes,
Yes, you are.
Okay, so recently there was a news that scientists have found phosphine in the atmosphere of Venus. So, is Venus a life-bearing candidate in the solar system?
okay, yeah. This particular thing was very much accepted once when we have detected the phosphine in the atmosphere of Venus. So what happens there is like, because the phosphine is one kind of compound that can't be created, you know, originally. There has to be something. There has to be something that actually create that phosphine, right? And that might be an organism too. That might, that organism actually uh, you know taking some sort of metabolism to either release it or either taking it, right? So these are the things that we have to think about. Now lately, once we like the other space agencies like NASA and ESA and few of the research institutes restudy the whole data, whatever the data that we have gathered from the Venus atmosphere about the phosphine, and then they analyzed there are certain amount of phosphine is there, but that is not the indication for life. We have to study, like they almost study like around 30 to 40 research articles for the same. They like analyzed that particular data like so many times to conclude the proper statement, and lately they said, okay, we do have found the phosphine in the atmosphere of Venus, but that is nothing related with life at right now, at least now. But once a Carl Sagan proposed one of the thing that life might be possible somewhere in the cloud of Venus, because it also have water vapors, right? So our human tendency is something like wherever there is water, there is life, and it is true. Wherever there is water, there is life. But the thing that we have to understand is wherever the liquid water is there, there is a life, right? So we have to reframe our sentences and we have to reanalyze the data. Then only we can comes into a conclusion that yes, that was a hype at that time that phosphine was present on the Venus, and that's we have find some sort of evidence of microbial activities or any sort of activities in the the clouds of Venus. But yes, lately they said no, this is not nothing something that you are thinking about. Yeah. And although you must have to know that water vapor is one of the strongest greenhouse gas also, right? So this is also a reason why our earth is facing some sort of greenhouse effect as well, so because of water vapor. Yeah.
Then if the phosphine gas isn't created by life or any microbial organisms, how is it created on Venus?
Uh, that is not confirmed yet, like how it was created, but whatever the data that they have analyzed, these researchers have analyzed, they actually concluded, okay, we have found a certain amount of phosphine, not a huge amount of phosphine. The thing is, like if you are looking at somewhere and suddenly you find the blink is there, you find, okay, the blink is all around the area, but the thing is only that particular area is blinking, the area that you are looking, right? So after that analysis, that they conclude, okay, only this zone have like certain amount of phosphine, but that is not that much. It's something like you are bringing 1 spoon of water out of ocean, and out of that 1 spoon of water you are saying, okay, there is something which is producing life there, right? This phosphine is created by that creature, but you left with the whole ocean, right? You haven't observed the whole ocean, you just have noticed one particular spoon. This is something like that, right?
Okay, sir.
Yeah.
Thank you for answering.
Okay, next, Keshava, you can ask your question.
Yes, sir. Am I audible, sir?
Yes, Keshava, you are audible, but just
Yeah.
try to say.
Yes.
Mhm.
Uh, my question is, why life evolves in planets and what part it plays in this cosmic ocean?
Can you please come again? Why life?
Evolves in planets
Mhm.
and what part it plays in cosmic ocean?
Okay, so yeah, the very first thing why life evolved in on planets, right? As in my lecture, if you notice, I talked about the three major things, that is energy, second is elements, and the third is water. Now, the thing is, first you have to understand that where the elements are come from and what are that certain amount of or certain kind of elements we can form. So our Earth's interior, if we are talking about the any terrestrial planet, leave, let's don't talk about Earth. Let's talk about planets. That planets have a terrestrial surface as well as the different compositions of layer. That compositions of layers have certain amount of minerals, certain amount of chemical elements, and 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 just above it, if there is a liquid ocean water or liquid water itself. Now, once the heat is there, because the internal heat is actually coming from the magma itself, right? If any terrestrial planet is there and they have certain amount of geothermal energy, that is nothing but it's coming out of from its a mantle, and that mantle itself have chemical elements, and these chemical elements are carbon, nitrogen, oxygen, sulfur, phosphorus. Now if I ask why you found phosphorus and sulfur near the hydrothermal vent, where it's come from, it actually comes from the magma. The magma have these all sort of gases, the magma have these all sort of chemical compounds in it, and once it finds a way to out from that layer to even in the ocean or even in the surface, right? They actually providing some certain amount of you is like life ingredients, you can say a life ingredient: phosphorus, sulfur, carbon, nitrogen, oxygen, like even water. So once they come out and when they react with each other, that leads to form a life. But the thing is, it takes a time. You can't create life within an hour there. It will takes a time. It needs time to evolve. Once it evolved, you actually find there are some kind of bacteria that are actually taking as the nutrition of sulfur, so that we call this as the sulfur secreting or a sulfur digesting bacteria. Then lately it came like evolved as a cyanobacteria that is actually releasing oxygen as a byproduct. It is actually taking sulfur, phosphorus, nitrogen as a nutrition, but it is actually releasing, oxygen as a byproduct. And that byproduct of oxygen will oxidize the whole scenario of that Earth's planet itself, right? To form a life as we found right now. Now, the same kind of pattern, the same kind of things even happening on other planets, right? So, like, if they have the elements, because the terrestrial planets actually shares a similar kind of a materialistic states, like Earth has silica, Mars has silica on its surface. Like if you find some another world, you can even see, yes, there is silica. Now silica is ultimately nothing but a sand. Okay, sand we can find on Earth, sand we can find on Moon. And same kind of thing, even the lava flow on Venus, because it is a terrestrial planet, lava flow can be seen in the Moon because it is a terrestrial moon, right? So these are some sort of criteria, and this is the reason why we found life on planets. But if you are talking about what if we found like life in wide space of universe and the wide space of our cosmos, now the thing is you need a medium to grow, right? Even if you want to grow life in your lab, you need a medium to grow it. What that medium could be, that medium should have the energy to provide it. That medium should have some kind of liquid to it. That medium should have a certain amount of chemical element to it. Then only life can form. But in the cosmic voids, we can't find the medium, we can't find the liquid water, we can't find the energy. Yeah, okay, all right. Energy can we can get the energy from some stars or some sort of uh, activities that are already the like dark energy and all these stuff. So that is not the point of consideration. But the thing is, we don't have the medium to grow it. That's why we don't find life in the voids. That's why we only found life either in on the comets or either on the on the planets. But why not certainly in the meteorites and asteroids? Because they don't have a certain amount of internal energy like a planet have, right? The process that we geologists know about, the differentiation and the fractionation that happen on planet, due to that differentiation different layer will formed, and that different layer ultimately decided to the fate of that planet, right? So this is why we call, and this is why we understand that okay, life needs to be a medium, right, Keshav?
Okay, sir. Thank you.
Yeah.
Okay, next Priyanshu Pradhan, you can ask your question. Priyanshu Pradhan, are you having any problem with? Okay, you can write your question in the chat box. Okay, so Priyanshu is asking, he has two questions. So do you use computer simulations in your field, and is non-carbon based life possible according to you?
Yeah. So basically, astrobiology is a multidisciplinary branch, right? It doesn't matter from which field you are belonging from. If you are from a computer simulation and computer design and computer softwares, we definitely need you, because we actually want to simulate things, right? We have to, there are certain softwares that actually helps to understand the fate of, the fate of the planet. Like for example, Earth is in its stationary zone and it is like revolving the way it is, right? Now, at some point, what the asteroid is coming from uh, the cosmic way. Now, what if that particular meteoroid or that asteroid impacted on the Earth's surface? What could be the scenario? So that simulation will help us to analyze and understand what could be the impact. What is the size of asteroid? That is also an important thing, because this is something which is very important. Like how much, what will be the intensity of the impact, right? And where it could happen. Based on these simulation, we can actually study it. Now, apart from that, if you are going to, analyze things in a microbial scale, right? So to, represent the like data, like for example, in our recent training program, we actually use four kind of different hands-ons, right? We added four kind of different hands-ons, in which hands-ons we use Artemis, we used some NCBI portal to create some phylogenetic, that's a different Rasmol. Yes, these two software basically for bioinformatics, that actually helps to analyze the type of protein and what is the structure of protein of any life have. Then we used a Giant 4. That Giant 4 actually a simulation software for to detect or to analyze the value of radiation that any thing can, or tolerate. Like suppose you want to create a one sort of habitat, and what is the material that you are using, and what is the, radiation value that it can, it can tolerate. So with the help of these softwares, based on these simulations, we can actually understand, okay, this is the certain amount of value that this particular material can face, right? So yes, we do need some sort of, computer simulations that are very essential for astrobiological research. And you might astonish after this, we can we can even use these simulations to write a research paper, and we actually did it. Yeah, we definitely did it. With the help of simulation, we are actually writing some research papers, because we get some analysis, we got some values that are pretty much accurate, and based on that accuracy and that simulation values, we are writing and we are suggesting something in our research papers, right? So this is the use of computer simulation in the field of astrobiology. Now, the thing is, whichever the field you are belong for, you have to think out of the box, like how you can correlate your, expertise in this field, right? Now, you ask your second question, that is non-carbon base life possible according to you? There could be possible, like there may be ammonia, like ammonia based life, right? There could be ammonia based life that does not even need a carbon, right? Carbon in the free state, that we call it as life on earth. Like what is the possibility of life on methane base and the ethane base, although they have carbon, but they can't be separated, right? So there might be also a possibility of silicon life, but I don't consider a silicon life is better. The reason is because silicon is highly reactive. It can even break easily, right? So due to that, like it can react with anything, almost anything, right? So this is not something what we want. But other than that, if there is alternate chemistry, that yes, we can find life also. And I believe, yes, there is, because adaptation is ultimately the fate of life and the evolution is the path. This is one sort of story that you can understand, right?
Okay, next, Vijay, you can ask your question.
Okay, so good evening, sir. It was a great session. Thank you for it. And
Hello.
my question is,
Yeah.
you said about the expeditions by Spaceonova to Ladakh and stuff. Like, how can people participate in that, sir? Is there any possibility for that?
Uh, yes, there is certain kind of thing that we are planning, that in the collaboration of Shulani University, because we have currently launched our official astrobiology club there. So in that expedition program, so we already like selected few of the students from the university itself. Now there are some sort of criteria that you have to pass, or based on these criteria, and if you are selected, right, for the expeditions, like around 4 to 5 people we are expecting from all over India. And based on your academic histories and academic your proposal for the site and all this stuff, once you qualify that, and we'll even give you few grants for the same, right? And yes, you can join there. So we'll let you know, this is something that we are currently working on, right? But soon we'll launching it. So don't worry about it. Just stay in touch with Spaceonova. We'll definitely let you know, right?
Okay, sir. Thank you.
Okay.
Next, Sakshi Singhal, you can ask your question.
Sir, thank you for an amazing session. Am I audible?
Yes, Sakshi, you are totally audible.
Sir, I just wanted to ask, what do you personally think? Do aliens exist? And if yes, why aren't they able to reach Earth yet?
I do believe they exist. Now, the thing is, why we haven't made any contact, right? Like I already said you before, we are actually looking at the just 1 degree of our vision. We are actually neglecting around 359 degree. Now, if we are looking at that particular location, then again we are lefting out with our another degrees. Now the thing is, because of few sort of evidences like the wormhole frequency, like the wow signal that we have received, then we have received the signal from uh, Proxima Centauri, right? So that Proxima Centauri is like very nearest sun to nearest star to us. And even we have detected some sort of signal that is a optical signal uh, like from a Tabby's star. That is a very unusual dip that we have found detected, right? But the thing is, we are not sure because we don't know if the alien life is exist, what sort of technology they are using. What we know, what we have developed a two kind of technology to communicate. That is a radio wave, and the another one is the optical, right? Now the question is that distance is so far, even if they are, transmitting their signal, it will take a long time. Like suppose if there is civilization which is living around 2400 light years away, and they are sending us a signal, and we just recently have developed our technology to detect a radio signal, although they have created their own, a radio signal kind of thing, that techno signatures, and they are sending it the signal, but we don't have the technology, right? We just created right now. They already created it and they already sent it, the signal to us. When we created it, the signal is already bypass us. Now another signal will take 2400 years. That distance is a barrier, right? And the speed is a barrier. What I usually say, I say speed of light is the fastest thing in the universe, but at the same time it is frustratingly slow. We can't we can't cover the distance, right, in a very short time of span. This is the thing. Because of few of the signals that we can estimate, and yeah, I'll tell you, it is the today's headline. I was checking my phone and I got one of the news that within our galaxy, within our Milky Way galaxy, we have detect one signal that is continuously repeating itself in every 18.18 minutes. Yes, it
Yes,
is
sir. Sir, exactly.
repeating it. Now, what is the source of that, the signal? Where exactly it is coming from? Even we have detected the location. Okay, this is the particular location. Now, we don't have, you know, that kind of telescopes to look into it, like, to get the very clear vision what is happening there. Even if we develop, even we have, if we are looking into it, we are actually looking into a past. We are not looking into a current scenario, we are looking into past. Maybe they were there, but by the time we can see there, they already like left the surface or the left the place, right, or the planet. So yeah, I do believe in aliens. Just the thing is, we have to be advanced enough to make a contact with them. And the thing is, we have to, identify what exactly the thing that we should have to look for. Like whether it is a radio telescope, we have to look for radio waves, we have to look for optical waves, right? These are the few questions, or there is something alternative, maybe infrared or something that we are not using right now. Right, so these are some sort of things that we have to work on, but hope we can find, because this is the question now, this is the question that we have around 50 billion, stars within our like sorry planets, 50 billion planets within our galaxy. Out of it, maybe any one planet have a life, maybe advanced. It's how it is be like fortunate to have life only on earth, or it's just a thing that we can find ourselves a privilege that God created humans, and mm, then he saw us and he don't want to love. Okay, like I don't want to create anymore, right? So this is the thing. uh, there are possibilities to find aliens, but we have to develop that much, from a technological level as well as intellectual level. So yeah, thank you, Sakshi, by the way, for the question.
Thank you.
Okay, next, Siva Shanket, you can ask your question. Your voice is not clear.
Am I audible?
Yes, you are now.
Yes, you are now.
Sir, life became possible on Earth because of the habitable zone that on Earth is. Sir, as we see day by day, sun's radius is increasing. Uh, sir, so we can say that the temperature on Earth is becoming to the temperature of Venus, and also we can say, sir, the temperature of Mars is becoming to the temperature of third planet. It is Earth. So we can say Mars is also becoming habitable in habitable zone. Sir, can we expect a life on Mars in coming years after some billions years?
In the future, even I'm considering there was a life in some ancient past, because we have seen some sort of sedimentation and some sort of geological evidences that actually replicates that yes, there was a life, right? And but the thing is that at some extent we have to understand this, that yes, our Earth, ultimately the fate is all depends on the sun, because we all know our sun is also evolving, right? That ultimately leads to expand, and it harness the interior planets such as Mercury, Venus, and even on Earth, right? So lately we have to leave Earth. This is the ultimate fate. We can't do anything because we can't control the energy of sun, right? We have to leave Earth. Now, for now, we can consider Mars as our home, right? The thing why we have sent the rover is to actually understand if life was possible somewhere at the ancient past in the history of Mars. So what was the reason why it was vanished from the surface of Mars, right? This is the crucial question that we have to solve. Like, what was happened to the life, to the environment, and to the atmosphere of Mars? Like, as currently we see the nothing but a dead planet. Okay, there is a possibility, there is a high possibility that we can convert that particular planet, that is, Mars, into a habitable world that we can sustain our life. But first we have to fix all these questions that already had happened to Mars. Like, it have a very low gravity, that we have to fix it. We have to, we have to adapt, and we have to do something to survive at that place. Like, although that particular planet have the very low electromagnetic ray, but electromagnetic field, because electromagnetic field is the one thing that is actually protecting you from the solar radiation, as well as protecting your atmosphere, right? So Mars have the very thin what I can say, atmosphere due to its magnetic field. So we have to fix that, because if you want to capture the atmosphere, you have to build, you have to give some sort of magnetic field into it, because this is what can protect the whole atmosphere. Like, suppose you haven't worked on it, so whatever you are creating, like how much amount you are creating for the atmosphere, you are providing the whole sort of oxygen, you are providing all sort of carbon dioxide, methane and ethane, and whatever it is. But until or unless you don't have the outermost cover to protect that atmosphere into its gravity, you can't form a life. So that's why we are sending our rovers, we are sending our orbiters to study detail about Mars itself. Once we work on these questions, these primary questions, how to solve the gravity, how to solve the magnetic radiation, how to solve the you know the atmosphere thing, how to solve the liquid water sustainability into the surface of Mars, and what is like until unless we haven't worked on the plantation and the agriculture thing, how we will survive. Once we solve all these questions, then we'll definitely colonize that particular planet, that particular red planet into Earth-like planet. This is why astrobiology is, and this is why what a space exploration agencies are doing, right? And once we colonize there, then our ultimate goal is to let's find another home into another star, right? So yes.
Sir, my another question is, sir, there are three types of aliens, sir, according to the theories. Sir, one is advanced and one is some others are there. Sir, if there are advanced aliens, sir, they can travel from another universe to our universe in fraction of seconds. Sir, then why are they not attacking on us, and why are they not visiting us?
So what do you want? They are going to attack us, and you want to be the dead. This is what you want.
No, sir. No, sir.
So
If aliens exist, they
yeah,
may do
exactly.
this. Why?
So
Why don't?
exactly, that was a something. So yeah, the thing is, there are basically three types of civilizations that we usually consider: that type 1, type 2, and type 3 civilizations, right? Type 1 civilization that actually harness the energy of the planet itself, like whatever the internal energy of the planet have, we can utilize all sort of energy into our survivors, and into our the technology thing. Like you need some sort of energy, you need some sort of fuels. If we can extract all these things from our planet itself, and we can use it as a fuel to run, right? So this is what civilization, type 1 civilization, to harness the entire energy of the planet. And currently we are doing it, but we are not in that state. That particular scale is called as Kardashev scale. So in that scale, we are actually lying somewhere in 6 and 7, point 6 and 7. I'm saying it point 6 and 7. And type 1 civilization is that civilization that actually harness the entire energy of planet, right? So we are not that much advanced. And if the civilization is that much advanced, right, that can actually utilize the entire energy of the planet, they might be there, but maybe we don't have the technology to detect them. Now the second thing is the type 2 civilization that is actually harnessing the entire energy of the star. They actually build some sort of a giant structures around the star to gather the their own routines and their own purposes to get metabolized for to eating foods and to grow foods and all sort of things, whatever it is. Now the thing is, we do have some sort of evidences of that, because as I already told you about the Tabby's star. Tabby's star is one kind of star that is actually showing a huge dip of luminosity that actually gives us a hint of Dyson sphere. A Dyson was one scientist that actually hypothesized structure that is actually covering the star and getting and using the whole energy of a star. Like for example, if you know, and I definitely know that you will know about the Thor movie, like I guess Thor, the ones that he want to make the X like, right? So they that was a I guess a neutron star, right? That was a neutron star, and he actually pulled whatever the wall is to get the energy to make that particular the hammer, or not the hammer but the axe. So yeah, these are the civilizations that are actually using the entire energy of the sun, and they have the some sort of the outer cover to cover the whole star. So these are type 2 civilizations. Now this is okay, this is somewhat friction, but this is possible based on evidences, because we are talking about the Tabby's star, that it might have the Dyson sphere, but we are not so sure about it, because the we are looking into it, but the data is so blurred now. It is so blurred by visual effect or by the radio telescope, by the radio waves. It is so blurred that you can't even explain what exactly was there. But yes, there was a dip in light, dip in luminosity, and it ranges a wide beyond. They made even last long for 186 days, 32 days, 84 days. That something is revolving around it, but it has a very giant structure. So these are type 2 civilization. Type 3 civilization is a civilization that can harness the entire energy of, Milky Way galaxy or any galaxy. They are like, damn, like they are in evolvement is something that beyond we think what sort of technology they are using, right? So these are the things they might, exist there. And I just want to ask, like, why they want to kill us? Like, they don't like us, or like our faces are not that much pretty. Like, they hate our faces. Like, why they want to kill us? Yeah. Anyways, this is something different kind of thing. Yeah. Yeah, yeah. Literally, Nitish. Like, we have like beautiful faces, right? Like, so why they want to kill us?
Sir, because they want to colonize our Earth.
So that's what they are doing now. That's what they are doing. They are actually using the entire energy to, harness the entire galaxy. So we are just trying to, colonize the another planet. We are so leap behind from you guys, right? So, anyways, like, even if we made contact in some near future, far future, we have to take the responsibility, like what to talk, how to talk, right? And does it harm to us or is it not? We have to create some sort of protocols. We have to take a in charge for the same. Maybe they are coming towards us, but due to that distance lag, they need some time to reach out to us. Maybe when they reached to Earth and they found we already trashed our Earth. We already trashed our Earth, and we leave it behind, and right now we are already in some other planets. And when they found, okay, they lived, now we can live there. So yeah, this is just some sort of things that we can think about, because this is something very hypothetical, right? Yeah, so
Thank you so much, sir.
Okay, so I guess no one else have raised their hands, so they don't have any more questions. So firstly, thank you, Anuj sir, for this wonderful presentation and spending your precious time with us and helping us all with this wonderful topic. And secondly, we want to thank every participants here for your diligent support towards us throughout this webinar. And also we have shared a Google form in the chat, and for attendance, please fill up that form. And only people who will fill up that form will get their participation certificate. So thank you. We can end our session here.
thank you, thank you so much. Thank you, Priyanshu. Thank you, Abhishek. Thank you, Vijayashri. Thank you, Nitish. Oh yeah. Okay. Thank you, Nitish. Thank you, Lakshmi. Thank you, Keshava.
Okay, so this session will end within 9 p.m. So please fill up that Google form within 9 p.m.
Okay, thank you so much, Koena. Thank you, Sakshi.
Okay, I'm providing with a Google form link. Okay, so yeah, okay, that's fine.
You can find me on LinkedIn. You can find me on Spaceonova's website, right? So you can contact there. Yeah, you can email me as well. This is my email address. So yep. Okay, so I have found few of the guys wants my Instagram username. Okay, so so this is somewhat I'll keep on you, like just search Anuj Soni, and if you find, you can find me, then you can send me a request and you can follow me, right? So like this is something, the effort that I want to expect from you, right? And let's stay in touch with there as well. Okay. So let's search something that actually gives, a potentiality to do a research work, like how to do research. This is kind of practice like that you usually do, that I can consider, right? So searching names, so that's totally fine. Yeah.